Hello students, hope you are doing well. In this video, we are going to discuss OpenFlow in Cloud Computing of Unit 6, Software Defined Network for the Subject Enterprise Network Design of B7 Semester IT University of Mumbai. In this lecture, we focuses on the role of OpenFlow in cloud computing. One of the promises of software defined networking and OpenFlow is the improvement that they can introduce in data centers and the cloud computing infrastructure. Therefore, it is worth covering the uses of OpenFlow like Floodlight plugin for OpenStack in data centers, and in particular OpenStack as one of the widely used control and management software for cloud computing. A brief introduction to OpenStack and its networking component and its overall architecture will be discussed in this lecture. So, basically, we are covering two topics, OpenStack and Neutron, and OpenStack networking architecture. OpenStack and Neutron, we here in this lecture, OpenStack is a cloud computing system software, sometimes referred to as Cloud Computing Operating System, which delivers infrastructure as a service (IaaS) released under Apache license. OpenStack is a free open source software. OpenStack Foundation was established in September 2012 as a non-profit corporate entity which manages the OpenStack project. It promotes OpenStack and its developer community. OpenStack includes a set of building block projects that control pools of computing node, that is, processing node, storage, and networking resources in data center. OpenStack provides a dashboard that enables administrators to control and provision the mentioned resource through a web-based graphical user interface. OpenStack's module architecture and its building block and their code names are shown in this figure. So in this figure, you can see dashboard. It is known as horizon, identity, keystone, and image is known as glance. Compute is developed under Nova. Storage managements are of two types, Swift and Cinder, and network is Neutron. OpenStack Compute, that is Nova, which is the main part of IaaS system, is the Cloud Computing Fabric Controller. Nova is written in Python language and it utilizes many external libraries such as SQL Alchemy for database access, Kombu for advanced message queuing protocol communication, and Eventlet for concurrent programming. Nova is able to manage and automate pools of computer resources and can cooperate with widely available virtualization technology and high performance computing deployments. It is designed to scale horizontally on commodity computers with no proprietary hardware or software requirements, and also to provide the ability to integrate with third-party technologies and legacy systems. Zen Server and KVM are typical choices for hypervisor technology. Along with the Linux container technologies such as LXC and Hyper-V, OpenStack utilizes two components for its storage management. Number one is Swift. It is used for object storage management. Swift is also known as OpenStack Object Storage. It is a redundant and scalable storage system. Files and objects are written to multiple disks across multiple servers in the data center. The OpenStack software is responsible for ensuring data integrity and replication across the cluster. By adding new servers, storage clusters simply scale horizontally. If a server or hard drive fails, OpenStack replicates its content to new location in the cluster from other active nodes. Since OpenStack uses software algorithm to ensure data distribution and data replication across different devices. Inexpensive commodity hard disks and servers can be used for storage management. Now come to Cinder. It provides persistent block level storage device for use with the OpenStack compute instances. Cinder, also known as OpenStack block storage. The previous one is the OpenStack software, and actually it is object storage. Previous one is used for object storage. Here you can see in diagram also, and in second that Cinder is block storage. So block level storage is provided here. Block storage is suitable for performance sensitive scenarios such as expandable file systems, database storage, or for providing a server with access to a raw block level storage device. Block storage volumes are fully integrated into Nova, that is, OpenStack Compute. An OpenStack's dashboard, this enables the cloud users to easily manage their own storage requirement. Powerful functionalities for backing up data stored on block storage volume is provided by snapshot management. Snapshot can be used to create a new block storage volume or simply can be restored. Now come to Horizon. This is dashboard. Horizon is the OpenStack dashboard. It provides a graphical user interface for users and administrators to provision, automate, and access to cloud-based resources. Third-party products and services such as monitoring, billing, and additional management tools can be integrated into Horizon. Using a native OpenStack API or the Amazon EC2 compatibility API, developers can automate access or build customized tool to manage their resource. OpenStack API are compatible with Amazon S3 and Amazon EC2. Therefore, client application with the design and developed for Amazon Web Services can be used with OpenStack. Now come to Keystone. This is identity. OpenStack identity component provides a central directory of users which are mapped to their accessible OpenStack services. It functions as common authentication system across the cloud operating system. It can also be integrated with existing backend directory services such as LDAP. Standard username and password credentials, token-based system, and Amazon Web Services logins are multiple authentication mechanisms which are supported by Keystone. Then come to Glance. OpenStack Image Service provides discovery, registration, and delivery services for server image and disk. Stored server images can be used as template. It can also be used to store and catalog an infinite number of backups. Glance can store disk and server images in a variety of backends, including Swift. A standard REST representational state transfer interface is provided by Glance for querying information about disk image and enables clients to stream the disk images to new servers. Neutron, this is formerly known as Quantum, is a networking component of OpenStack. It manages network and IP addresses. Effectively, from Folsom release, Neutron is a supported and core part of OpenStack platform, like other part. Okay, like other part of cloud of a component of cloud operating system, administrators and users can utilize Neutron to increase the utilization of existing resource in data center. Neutron provides networking as a service and AES, so you can understand that it is very important. Between this NAS is between interface device like virtual network interface card (VNICs), which are managed by other OpenStack services. OpenStack Neutron provides networking model for different user groups or applications. Standard model includes VLANs, virtual LANs, or flat network for separation of network traffic among different servers. Neutron also manages IP addresses which can provide dedicated static IP or DHCP based IP addressing. Floating IP addressing allows packets traffic to be dynamically routed or rerouted to any of the computing nodes, which is facilitated by traffic redirection during virtual machine migration, maintenance, or failure handling. Extensible architecture of Neutron paves the way for additional network services such as firewall, intrusion detection system, virtual private networks, and load balancing to be deployed and managed. The networking component of OpenStack provide OpenStack's users with an API to construct rich networking topology and configure advanced network policies to construct multi-tier web application topology. The modular structure of Neutron facilitates the development of innovative plugins which actually introduce advanced network capabilities like L2 in L3 tunneling to bypass 4096 VLAN limitation, end-to-end quality of service guarantees, and utilization of monitoring protocols such as NetFlow and OpenFlow plugins. Besides, developers can develop advanced network services that integrate into OpenStack tenant network using plugins like Data Center Interconnect AAS, IDS AAS, Firewall AAS, and VPN AAS. All AAS is application as a service. And load balancing application as a service are few typical advanced services to mention. Using Neutron, users can create their own network, control traffic, and connect servers and device to one or more network, which administrator can take advantage of SDN technology, for instance, OpenFlow, to provide high level of multi-tenancy and scalability. Now come to OpenStack networking architecture. OpenStack networking architecture, Neutron is able to utilize a set of backend calls plugins that support a growing set of networking technologies. These plugins may be distributed separately or as a part of main Neutron release. OpenStack networking or Neutron is a virtual network service that provides efficient API to define the network connectivity and addressing that is used by a device from other OpenStack services such as OpenStack Compute. The OpenStack networking API utilizes virtual network subnet and port abstraction to describe networking resources. In the OpenStack networking ecosystem, network is an isolated L2 segment. Here you can see in this diagram also, similar to the virtual LAN in the physical network. A block of IP version 4 or IP version 6 addresses and associated configuration status subnet, a connection point for attaching a single device such as the NIC of virtual server to a virtual network is defined as a port. Also, a port describes the network configuration parameters such as MAC and IP addresses, which are associated to the port. By creating and configuring network and subnets, user can configure rich network topologies and then in structuring other OpenStack services such as OpenStack Compute to connect virtual interface to port on these networks. Neutron particularly supports each tenant having multiple private network and enables tenant to choose their own IP address scheme. OpenStack Network Service provides advanced cloud networking scenarios such as constructing multi-tiered web applications and enabling applications to be migrated to cloud without IP address modification. Enables cloud administrators to offer flexible and customized network offerings. Provides API extension that lets cloud administrators expose additional API capabilities. These new capabilities are typically introduced as an API extension and gradually will become part of the core OpenStack networking API. The original OpenStack compute network implements a very simple model of traffic isolation through IP tables and Linux virtual LANs. OpenStack networking introduces the notion of plugin, which is backend implementation of OpenStack networking API. A plugin can use different technologies to implement the logical API request. Some OpenStack networking plugins might use basic Linux virtual LANs and IP tables, while other might use more advanced technologies such as L2 in L1, L3, L2 in L3 tunneling to OpenFlow to provide similar capabilities. The main module of the OpenStack networking server is Neutron server. Here you can see, okay, and which is a Python daemon that exposes the OpenStack networking API. It passes user requests to the configured OpenStack networking plugin for extra processing. The plugin typically needs a database for persistent storage. If you deploy, if or your deployment uses a controller host to run centralized OpenStack compute components, you can deploy the OpenStack networking server on the same host. However, OpenStack networking is completely standalone and can be deployed on its own server. Based on deployment, OpenStack networking also includes additional agents that might be required. The plugin agent, that is underscore neutron star under plugin agent. Okay, it is written in network node and a compute node also, which executes on each hypervisor to configure a local switch. Since some plugins do not actually require an agent, the agent to be run will depend on the selected plugin. The DSCP agent, Neutron DSCP agent, okay, here third from left, provide DSCP services to tenant network. The L3 agent, Neutron L3 agent provides L3 slash or L3 or network address translation forwarding to facilitate external network access for virtual machines on tenant network. These agents interact with the core Neutron process through remote procedure call RPC by utilizing standard OpenStack networking API. OpenStack networking relies on Keystone for the authentication and authorization of all API requests. Nova interacts with OpenStack networking through standard API calls during the virtual machine creation process. The Nova communicates with the OpenStack networking API to plug each virtual network interface card on the virtual machine into a particular network. Horizon integrates with the OpenStack networking API and enables tenant users and administrators to create and manage network services through the GUI of Openstack Dashboard. There are four distinct physical data center network in a standard OpenStack networking deployment. As already shown in this figure, data network connects to virtual machine inside the cloud setup, and it is not there in this figure. Okay, here external network and API network is shown. Network connectivity for physical host, management network, It is used for internal communication between OpenStack component. IP addresses assignment of the network should be only reachable within the data center network. Then data network. This data network, it is used for virtual machine data communication within the cloud setup. Depending on the user used networking plugin, the IP addressing requirement of the network varies. External network. It is used to provide the internal access for virtual machines in some deployments. IP addresses on this network plugin network should be visible and reachable by any host on the network. And then API network. It exposes all OpenStack APIs, including the OpenStack networking API, to tenant. IP addresses on this network should be reachable by anyone on the network. In this lecture, we have covered OpenStack and Neutron OpenStack networking architecture. Neutron is an OpenStack project to provide the networking as a service among interface devices known as virtual and ICs managed by other OpenStack service Nova. Starting in the Folsom release of OpenStack, Neutron is the core and supported part of the OpenStack framework. Here, the key building block of OpenStack, including Neutron networking component and backend plugins sufficient, specifically Floodlight plugin were introduced. The Neutron API it includes support for L2 networking and IP address management. The API extensibility platform include extension for provider network which maps Neutron L2 network to specific virtual LAN in the physical data center network. And L3 routers support a simple L3 router construct to router between L2 network. So this is all about this lecture. In next video, we will discuss case study how SDN changed traditional enterprise network design. So this will be our last topic. So thank you very much. Have a nice day. Have a nice time. Bye bye.